Hello friends, welcome to our channel Mechanical Motivator. In this video, we are going to see multiple choice question on dynamics of machine from the topic unbalanced forces of reciprocating masses and balancing of locomotives. First, we are going to see primary and secondary unbalanced forces on reciprocating masses. The primary unbalanced force is maximum only at theta is equal to 180 degree. The primary force is maximum twice in one revolution of the crank, and normally they will be giving a formula like Fp is equal to m omega square r. So second question they are asking the partial balancing means. So normally to balance the reciprocating masses partially, that is called as partial balancing. In third question they will be telling like due to the partial balancing of reciprocating masses, there is an unbalanced primary force along the line of stroke, and also an unbalanced primary force will be perpendicular to the line of stroke. Since it's perpendicular, it's 90 degree. The secondary unbalanced force will be maximum, as we saw already 180 degree, we saw previous question. The secondary force is maximum 4 times in one revolution of the crank. 4 times in one revolution of the crank. So keeping large distance between connecting rod and crank minimizes the effect of secondary forces. So in next, actually I'm not going to read the question. We'll just give the explanation part alone. So the swaying couple will be maximum or minimum when cos theta plus sin theta is maximum or minimum. So when cos theta plus sin theta is maximum minimum, at that point the swaying couple will be maximum or minimum. So when should they be maximum? That is tan theta equal to 1. So at that point only the swaying couple will be maximum. So we will be getting an angle as theta is equal to 45 degree or 225 degree. And common formula is this is the formula for identifying. So B is the correct answer. So in next question, the same explanation. So we previously saw, right? So when should the swaying couple should be maximum? So when sin theta or cos theta maximum or minimum, at that point only the swaying couple will be maximum or minimum. So tan theta will be equal to 1 and theta will be 45 degree or 225 degree. The previous question only we saw. Next question is dealing with tractive forces. So tractive forces is maximum or minimum when cos theta minus sin theta is maximum or minimum. So when cos theta minus sin theta is maximum or minimum, at that point only tractive forces will be maximum or minimum. So for that purpose, tan theta should be equal to -1. So theta, an angle which we will be getting is 135 or 315 degree. And next question, and so this is the 8th question, right? Yeah. So swaying couple is due to what is the reason, right? The unbalanced force along the line of stroke. The unbalanced force along the line of stroke for the two cylinders constitute a couple. This couple has a swaying effect about a vertical axis and tends to sway the engine alternatively in clockwise and anti-clockwise direction. Hence, we will be getting a couple, right? And that couple is called as a swaying couple. And the main reason is it's mainly due to primary unbalanced forces. So ninth question, it deals with, actually this is the definition for hammer blow. So normally what is hammer blow is maximum magnitude of unbalanced force along the perpendicular, it should be perpendicular to line of stroke. So that point is called as a hammer blow. The effect of hammer blow is to cause variation in pressure between the wheels and the rail. So try to know the definition of hammer blow. Now you're going to see multiple choice question on partial balancing of locomotives. So first question, it will be dealing with what is the total number of cylinders? So what is the total number of cylinders in a locomotive having crank at right angles, right? So how many cylinders will be having? Locomotives usually have 2 cylinders with crank placed at right angle to each other. This is done in order to have a uniformity in turning moment diagram. So next we will be having second question. Second question will be dealing with for a 2-cylinder, that is for a 2-cylinder locomotive, the cranks are placed at right angles to each other. It's true, right? So just now we saw So for locomotives, generally two cylinders having cranks are placed at right angles and 90 degrees to each other for having a uniform turning moment diagram. And next question is 12th question, right? So next we're going to see in an inside cylinder locomotive, the position of the driving wheels is, so for inside cylinder locomotive, the two cylinders are placed in between the two driving wheels at an angle of 90 degrees to each other. So actually the position of driving wheels will be outside the cylinders. So cylinders will be inside, I mean between the driving wheels, right? So obviously answer would be outside the cylinder. The next question is just the opposite of it. The in and outside cylinder locomotive, what is the position of driving wheel? So normally what happens in outside cylinder locomotive, the two cylinders are placed outside the two driving wheels at an angle of 90 degrees to each other. So answer would be inside. So those cylinders will, I mean the wheels will be, driving wheels will be placed inside the inside cylinder. And next question is a single or couple locomotive is the one in which the effort is transmitted to one pair of the wheels only. So it is transferred to one pair only and not two pair. And next one, in a couple locomotive, the driving wheels are connected to a leading and trailing wheel by an outside coupling rod only. It's outside, not inside or side away or bottom. It's outside coupling rod. So now we can see a diagram here, right? So they are asking us to identify the type of locomotive. So these things just now we saw. So by seeing the diagram itself, we can easily tell the given figure is an inside cylinder locomotive. In inside cylinder locomotive only, the two cylinders are placed between the two driving wheels at an angle of 90 degrees to each other. So answer would be inside cylinder. And next figure, they are asking us, is this a locomotive for a four-cylinder locomotive? So obviously by saying it's wrong, okay, so it's a false one, because the given figure is an inside cylinder locomotive, since there are two cranks at right angles to each other, and it's a two-cylinder locomotive, not four-cylinder locomotive. And next thing, they are asking us to identify the type of locomotive from the figure. So by looking at the figure itself, you can easily tell so what kind of locomotive it is. So given figure is an outside cylinder locomotive. In an outside cylinder locomotive, the two cylinders are on either side of the two driving wheels at an angle of 90 degrees to each other. So do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload. Thanks for watching this video. Have a great day.